I've actually shown you this question before, probably a few months ago. But it's giving us this voltage used by most households can be modeled by a sine function. The max voltage is 120. There are 60 cycles every second. So if I were to kind of draw a quick graph and let this be 1 second, there are 60 cycles completing themselves within that 1 second's time. So it's a sine, so it's going up and down and up and down and up and down 60 times within 1 second. So the question is, how long is the period? If 60 of those fit into 1 second, how long does it take to complete one cycle? 1/60th of a second, exactly. Very good, Mason. So 1/60th of a second is your period. So period is 1/60th equals 2 pi over b. So you look at you kind of wrap your head around that, and then you can just solve for b and you're done. Because the maximums are all 120. So that's not helping you, unfortunately. And then just cross multiply, you get b equals 120 pi. And that's it. B is 120 pi. So option 4. It's just kind of wrapping your head around the fact that multiple cycles are happening within a 1 second time frame and figuring that out. All right, and then 37. So drugs break down in the human body at different rates and therefore must be prescribed by doctors carefully to prevent complications such as overdosing. Okay, so there's a little bit of fluff, just a little context and background. The breakdown of a drug is represented by this function, and they define the variables for you. N of T is the amount left in the body. N sub 0 is the initial dose. R is the decay rate, and T is the time in hours. Patient A of T is given 800 milligrams of a drug with a certain decay rate, and patient B is given 400 milligrams of another drug with a decay rate. So they each have a different starting amount, different decay rate. Write two functions. So we're going to have an A of T function, and what's patient A's N sub 0? What'd you say, Nate? 800, good. E to the negative, their R for patient A is 0.347. There's patient A. Negative 0.347 T as its exponent. And then patient B just has a different starting amount of 400 and a different decay rate of 0.231. Keep in mind that the decay rate is 0.231. The formula itself has the negative already in there. Do you see that? 0.231 and your T. So write two of the functions, done. Graph each function. Now we're going to have to be a little bit tricky here with Windows because, and we'll type it into our calculator. You can just watch me for the sake of time. E to the negative 0.347x, and then our second patient, 400, e to the negative 0.231x. Oh boy. Negative 0.347. Okay. They're starting with 800 milligrams and 400 milligrams. So on our y-axis, we want to make sure this goes up to at least 800. And then as far as the amount of time it's going to take, time is in hours. Let's just look for a 12-hour period and see what happens. And if we need to go to 24 hours, something nice, we can do that. So if I graph this, there's patient A. Pretty good because I'm getting down to having nothing left in the system. And pretty good there. So again, though, when you're graphing, use exact points. Look at your table for these two patients. And you don't need to graph every point, but you can start by doing, you got a scale. So 1, 2, 3, 4, 5, 6, 7, I'll count Every other line is 100. And I'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe I want to just graph a point every 6 hours. So 0, 800, 699. That's a quick drop. And 12 is going to be really small, 12, 12. So that's pretty much 0 on this scale. So I'm going to do a quick sketch of that. I would be more exact if I had more time. And then on your other one, you've got 0, 400, 6, 100. The other one was 699, so they're almost kind of on top of each other there. And then 12, 25, so it's just a little bit higher. We will finish this one tomorrow because the second one actually requires some solving. Your homework is just to finish June 2016. Okay? Yeah. I do. If you weren't here on Friday, I do have books for you.